So let's consider this example. The limit of the greatest integer function x minus 3 as x approaches 3. Recall that, yung definition natin ng greatest integer function, x is greater than or equal to n, but less than n plus 1. Tama? So, sinasabi kasi ng greatest integer function natin, kukunin lang natin actually yung greatest integer garod. So, greatest na integer na hindi sosobra. Okay, sa kanya. So, in this case, ito yung integer na yon. Okay? So, hindi siya dapat equal kay n plus 1. Pero, alam natin that the value of x, dito siya sa loob ng interval natin na ito. Okay. So, by the definition of the greatest integer function, we say that x minus 3 is greater than or equal to n, but less than n plus 1. By some algebraic manipulation, so ang gagawin natin, itatranspose natin yung negative 3 to both sides. Both sides dapat, hindi lang isa. So, we have, ipat dyan. So, we have n plus 3, note, nag-change tayo ng sign. So, we have x here, and then we have n plus 4. So, x now is greater than or equal to n plus 3, but less than n plus 4. So, what does this mean? So, ano ang ibig sabihin ng x is greater than or equal to n plus 3 but less than n plus 4? So, kung isusulat natin yan, the greatest integer function x minus 3 now is actually equal to the piecewise function. Okay, so marami yan. We have 1 for x greater than or equal to 4 but less than 5. 0 siya for x greater than or equal to 3 but less than 4. 1 siya for x greater than or equal to 2 but less than 3, and so on and so forth. So, paano natin nakuha ito? Ilalagay mo lang yung n mo, okay, or yung x mo dito. So, we have, kunwari, 1 ito. So, x now is greater than or equal to 1 plus 3. So, we have 4. 1 plus 4 equals 5. So, ganun lang. 0 naman siya, kasi pag nilagay mo yung 0 doon, we have 3 up to 4. And so on and so forth. So, kung meron tayo ditong, sorry, this is negative 1 pala. This is negative 1. So, kung meron tayo ditong negative 2, ano dapat siya? Negative 2 plus 3, that is 1. And negative 2 plus 2, that is 2. And so on and so forth. Now, ang gusto natin, kunin yung limit na ito. Okay? So, we need to check yung less than 3 at yung mga greater than 3. Now, we wish to find the limit of this. So, we need to check the limit from the left and from the right. So, the limit of our function as x approaches 3 from the left. So, tignan natin dito, nasaan ba yung less than 3? Eto, tama? So, gagamitin natin yun. So, we have actually the limit of negative 1 as x approaches 3 from the left, which is equal to negative 1, limit of a constant. For letter B, we have the limit of the function as x approaches 3 from the right. Tingnan naman natin, alin dito yung x greater than 3? Eto. So, we have the limit of 0 as x approaches 3 from the right, or that is actually equal to 0. And since the two limits are not the same, are not equal, then we say that the limit of this function as x approaches 3 is actually D and E, or the limit does not exist. Now, let's consider this function. N of x is equal to the greatest integer function 3x plus 2. And we wish to find the limit of n of x as x approaches negative 1/3 from the right. B, the limit of n of x as x approaches negative 2/3 from the left. And C, the limit of n of x as x approaches negative 1/4. By the definition of greatest integer function, we know that 3x plus 2 is greater than or equal to n but less than n plus 1. So by algebra, transpose natin yung 2 to both sides. So we have n minus 2 and we have n minus 1. Again, kailangan x lang yung maiwan sa gitna. So we divide everything by 3. So we have x now is greater than or equal to n minus 2 over 3 but less than n minus 1 over 3. Okay? So we have n minus 2 over 3, n minus 1 over 3. So if we set up the piecewise function, for that we have okay, so the piecewise function, medyo marami-rami ito. So we have 1 whenever x is greater than or equal to negative 1/3 but less than 0. Tama ba? Okay, kapag 1 yung nilagay natin dito, okay, tama. Negative 1/3, tapos dito 0. 0 naman siya kapag x natin is greater than or equal to negative 2/3, but less than, pag 0 yon, negative 1/3. Then, negative 1 siya kapag negative 1. Kasi negative 1 minus 2, negative 3 divided by 3, so negative 1. But less than negative 2/3. Negative 2 naman siya kapag x natin is greater than or equal to negative 4/3 but less than negative 1. And so on and so forth. So going back to our function, we wish to find the limit of n of x as x approaches negative 1/3 from the right. So hanapin lang natin alin yung limit na yon. So x is from the right, greater than dapat. So ito yon, 1. As x approaches negative 1/3 from the right, and the limit of the constant is 1. For letter B, we have the limit of n of x as x approaches negative 2/3 from the left. Okay, hanapin naman natin nasan yung x is less than negative 2/3. Ito, negative 1. So the limit of negative 1 as x approaches negative 2/3 from the left is equal to negative 1. For letter C, we wish to find the limit of n of x as x approaches negative 1/4. So in this case, tignan lang natin, negative 1/4. Meron bang negative 1/4 sa end points natin or sa end ng interval? Wala. Pero alam natin that negative 1/4 lies here. Tama ba? Andito yung negative 1/4 natin sa part na to. Therefore, pwede lang natin gamitin yan. Okay? Hindi na natin kailangan kunin yung left or right kasi nga nakapaloob na siya dito. Unlike doon sa dalawa kanina na nasa endpoints. So we have equal to the limit of 1 as x approaches negative 1/4. Therefore, this is now equal to 1. So in summary, kailan natin ginagamit yung one-sided limit kapag sa greatest integer function? So ginagamit natin siya if the endpoints, let's say, limit of f of x as x approaches a, okay? And then yung greatest integer function natin is equal to a sub 1, a sub 2, a sub 3, for example. Whenever andito yung a natin, x is greater than or equal to a but less than b, x is greater than or equal to c but less than a, x is greater than or equal to d but less than c. So parang ganyan. Ginagamit natin siya kapag yung a natin is nandoon sa endpoints. Otherwise, pwede lang nating tignan kung nasaan yung value ng x natin. So in this case, since si a ay nasa endpoint, then we have to use one-sided limit to evaluate the limit of f of x. So that is the limit of f of x as x approaches a from the left at limit of f of x as x approaches a from the right. And for this to exist, both of them should exist and should be equal.